Hello, everyone. So welcome to this week's Why Now. Today we have Jay Patel. He is a grad student in the HST program of Harvard MIT, and he's going to be talking to us about Python today. So without further ado, Jay, it's over to you.
Hi, everyone. Hopefully you can hear me now. So yeah, this is my first time giving a virtual talk, so we'll see how this goes. But yeah, we're going to do an introduction to Python today. And let's begin. So, okay, the general outline for this talk is we're going to very, very briefly discuss what Python is and why we want to use Python, and spend the majority of the time on how we can use Python, going over what IDEs are available, what types and operations are used in Python, containers, basic control flow, so your for loops, conditional statements, things like that. And then the most relevant part of the talk is probably scientific Python. So what type of packages exist for high efficiency numerical computation, which is probably what most people like yourselves would like to use Python for. So what is Python? So Python is a interpreted high-level programming language. So for those that are unaware, the difference between a compiled language and an interpreted language is that a compiled language, such as C++, it requires a compiler to translate the source code to machine code before executing the script. And this allows the executable to be a lot quicker, run a lot quicker. But there's also a lot of cons with this, in that it's not as easy to debug or easier to test out. Whereas Python or MATLAB, for example, is an interpreted language. So you can execute source code directly without any prior compilation. And yeah, as I mentioned, this makes it a lot easier to debug, and it's a lot more intuitive to use, I think. And another major thing about Python is that it's open source. It's free, and it's very community driven in terms of what packages exist and external toolboxes. So why do we want to use Python? So there are a lot of benefits of Python. As I mentioned, it's very intuitive and easy to program in, and it does this without sacrificing a lot of power. It's also open source, and it's one of the most commonly used programming languages in the world, which gives it, which means that there's a lot of packages out there that are well developed and well maintained. Python's also very versatile, so you can make some very nice visualizations, both 2D and 3D, and it runs on most operating systems and platforms. So some small cons is that it tends to be slower than a pure or compiled language like C++. And another con is that because it's mostly an open source endeavor, smaller / more specialized packages might not be well tested, in the sense that they will likely be bug ridden and require a lot of manual fixing of the code, or they might just not be maintained for newer versions of Python that you might be using. And this is in contrast with MATLAB, which if you were at the talk yesterday, you would know, or last week, you would realize that MATLAB, because it's a commercial software, all the packages that they output are very well polished. Okay, so now we're gonna go straight into how to use Python. So to start, we want to use Python 3 from now on. Python 2.7, as of January 1st, is no longer maintained, which just means that they won't be releasing any more security fixes or bug fixes for it. And yeah, if you have code in Python 2.7, it's probably best to transition it to Python 3 now. But pretty much any Python 3 installation will work. Python 3.6 and 3.7 are the most common ones nowadays. The next step is to install any dependencies. As I said, Python is has a wide range of packages available to it. So you have NumPy, Matplotlib, SciPy, Nebabble, Pandas, scikit-learn, etc. And we'll talk about a few of these later in the talk and how to use them. But for now, these are probably some of the more common ones that you'll run into. Next, you need an IDE of your choice. So for example, when you download MATLAB, it comes with a very nice piece of software where you can edit your code and everything else. For Python, you only get a terminal window, and so most people choose to download an external IDE. I personally use Visual Studio Code, but there are tons and tons of IDEs for Python, and I'll direct you to the Stack Overflow question for what IDE to use for Python. Or you can run code interactively in a Jupyter notebook, which is also what I do. For the Stack Overflow question, if you go to that page, someone has posted this table, and you can just see right here how many IDEs there are and the different types of tools they provide. Really, it's a matter of personal preference which you choose. As I said, I use Visual Studio Code, but other people have other preferences. It doesn't necessarily matter too much at the end of the day, though. Okay, so moving on, let's talk about types and operations. So the basic types in Python are, you have your numerical types, so you have integers, you have floating point numbers, and you have complex numbers. Then you also have Booleans, which are your true, false, and strings. Your basic operations, there are many, many operations in Python. This is a very non-exhaustive list.
Hi, Jay.
Yeah.
One of the participants has a question.
Yeah.
I thought it's better to ask this now because it might hinder the, yeah, so he's asking what is an IDE?
Oh, yeah, so an IDE is just a tool to code in, essentially. So as you mentioned, it's an interactive development environment. And so what it allows you to do is, while you're coding, it can do things like autocomplete based on what methods you've given. It has debugging tools built into it. So you can step line by line through your code to figure out where, if there are any issues. Most have some terminal type option. Perhaps, Mainak, do you have a better explanation for how you'd say IDEs?
Yeah, I think that's a good explanation. It's just an interactive environment where you have auto-completion and ways to debug your code. So it's an integrated development environment. So it has you have the terminal as well as the editor all in one window.
Yeah. So essentially, yeah, when you download Python, it only comes with a terminal window. And so most people require some sort of debugger, and things like auto-completion are just quality of life tools. And so these IDEs kind of package all that into one software. And it's just much easier to code in that as opposed to the terminal that comes standard with Python.
Okay. Yeah, that sounds great. Thanks a lot.
Yeah. Okay, so moving on. So the operations, of course, non-exhaustively, you have addition, subtraction, multiplication. Taking powers is slightly different than MATLAB. In MATLAB, it's a caret symbol, but in Python, it's a double multiplication. So just something to remember. The percent symbol is the modulus operation. In is a very common operator in Python as well. It checks if an element is in a container. And I'll explain more what that means when we get to the container section. We also have functions in MATLAB. So a function is something that takes one or more pieces of data as arguments and returns an answer. So in this case, len is a function that tells you how many characters or pieces of data are in what you're passing in. So in this case, len of world will give you 5 because they're 5 letters. Methods are functions that are called directly off the data using the period operator. So for example, a built-in method in Python is the split operator. So if you have hello world.split, it'll split this joint string into 2 strings at where the space is. But we'll talk more about functions and methods in a little bit. Okay, so from now on, there'll probably be a lot of examples. I've copy-pasted a ton from a Jupyter notebook that I have. And so let's just start from the very basics and move upwards. So numerical types, integers, as I mentioned, is simply just a non-floating point number. So 1 + 1 = 2. Or you can assign a variable a to the integer value of 4. Floating point, same concept. Now you add a decimal point. This is pretty self-explanatory. And for complex numbers, same thing, where you have the real part of the complex and the imaginary part. And what you're seeing here is this is real and imag are methods of complex, which allows you to call to figure out what the real portion is and the imaginary portion. Okay, so the other basic types, Booleans and strings. Once again, this is also fairly self-explanatory. If you have, if you want to compare two types, this will give you a Boolean back. 2.5 less than 10 is true. 3 greater than 4 is false. So on. Strings are the final type that we'll cover. They're instantiated with either single apostrophes or double apostrophes. In Python, I don't believe it matters which you use. I think most people use single apostrophes for just out of habit. To index through the string, you can use the brackets. And so if you attended the MATLAB talk last week, you would know that MATLAB is 1 indexed versus Python, which is 0 indexed. What that means is that if we call my string equals hello world, and we're looking for the first element in this string, we actually have to call the 0 because Python is 0 indexed. And so the 0th element is actually the H. And so it's just something to remember when you're coding between MATLAB and Python. If you frequently use both, sometimes you can forget that one is 0 type, the other is 1 indexed. And then finally, this is just something to keep in mind as well about how methods affect the source data type. For example, take the string that we instantiated, my string equals hello world, and we're going to call the method replace to replace the word world with why and how. And we're going to print this. If we print this, what happens is that we first print hello, why, and how, but when we call the original variable again, it still says hello world. And that's because it did not, the variable myString did not account for the new replacement. To do that, you have to call myString equals myString.replace. And now if you reprint it, you get hello, why, and how. Hopefully that was not too confusing. The entire point here is that sometimes methods don't replace the data that's stored in that variable. They only temporarily do. Okay, moving on. Variable assignment. This is just some like tips and tricks in Python. A lot of times you see people doing things like this in MATLAB or Python where they have multiple variables they need to instantiate at the very beginning of their script. So let's say you have var1 equals 1, var2 equals 2, this is supposed to be 3 equals 3. And then you're also setting a few letters to the same variable. To speed this up, what you can do is that you can actually just say variable 1, comma, variable 2, comma, variable 3, comma, equals 1, 2, and 3. And this just makes the your code more compact and easier to read. And same with if you're setting multiple variables to the same output, you can just say x equals y equals z equals alphabet. And once again, that's just for pure, to make everything more compact and more readable. And then if you needed to switch two variables with each other, you could use this kind of syntax. But once again, this is just extra stuff. Okay, so containers. Now we're going to get into like more of the Python meat. So there are a few different containers in Python, or objects as you can call them, but the three main ones, the ones that you'll use 95% of the time, are lists, tuples, and dictionaries. So starting with lists, lists are a mutable set of objects. So what that means is that you can, when you instantiate a list, you can change it dynamically after it's been instantiated. So in this case, we're setting a list equal to the string 1, the integer 1, and the floating point number 1. And a list is instantiated by brackets. That's very important. A tuple is an immutable set of objects. Immutable meaning once you've set a tuple, you cannot change it without essentially just copying that tuple to a new location in memory and creating a new variable. And tuples are the same as, tuples can do essentially the same things as lists, but they're instantiated with parentheses. Finally, you have dictionaries, and dictionaries match a key to a value. So in this case, we're going to match the key, the string 1 to the integer 1, the string 2 to the integer 2, the string oh, sorry, I got confused. We're going to match the integer 1 to the key string 1, and the integer 2 to the key string 2. This is kind of confusing, but in any case, the point is that a dictionary matches an arbitrary key to an arbitrary value. And so this is very useful for if you have, say, some sort of like patient dictionary where you want to match patient names to their addresses, or patient names to some other key value. And each of the above has its own set of methods, which we'll walk through in the next few slides. So first, let's talk about when to use one container over another. So for lists, you want to use this if you need to append or insert or remove data from that collection of arbitrarily typed data often. So for example, if you know you're going to be adding new patients, or if you're going to be removing patients, or so on, then lists are the container you should use. You should be using tuples if you're defining a constant set of values and then you don't intend to change it. And the reason being is that it's actually faster to iterate over a tuple than it is to iterate over a list. For example, if you know you're always going to be looking at, searching over these 10 patients, then if you put them into a tuple, it'll actually be marginally faster to loop through them. And finally, as I mentioned, for dictionaries, you should use a dictionary if you need a key value pairing structure. So searching for a person's name, a key will provide their phone number, which is the value. Okay. So next, we're going to talk a little bit about indexing. So indexing in Python works somewhat similarly to how it does in MATLAB, with the exception that, of course, indexing in Python is 0-based as opposed to 1-based, and there are slightly different rules for how you can do it. So let's create a list that's the string one, the integer one, and the floating number one. With this list, we can append values, so we can append a complex to it, and now it has a complex value. And then we can insert this string one at an arbitrary position. So we're going to insert it at position 1. Now, to index through it, if we take the 0th index, we get the 0th value. So this is the lowercase 1. If we want to get the second to last element, we can take the negative second position, essentially, and that'll give us the second to last element in this list. If we want to get the first 3 elements in the list, we can use a colon operator. So this tells us we want all the values in this list up to the 3rd one. And so you get a list of 3 values. If you want the last 3 elements, it's the same concept as before, where you take the negative 3rd colon values, and that gives you the last 3 elements. And then you can use some more fancy operators. So if you use a double colon, this will give you every second element in the list. And if you want to reverse the list order, you can do 2 colons and -1. So these types of indexing operations can, of course, be done with different types of methods and functions. For example, if you wanted to reverse the list order, there are Python functions that you can call that will do that for you. But you can also do it yourself via this list indexing approach. Okay. Now I want to talk about just a few different programming paradigms. And the 3 main approaches are if you're scripting completely, if you're using a function, or if you're using some sort of object-oriented approach. And so what does that mean? So scripting is when you are working entirely in your terminal window, essentially. So you're completely interactive. And so we set num1 equals to 3.4, num2 equals to 4.89, and then we're in the terminal window adding these 2 numbers and printing the sum. This is fine if you're only doing it a couple of times, but oftentimes if you want to call the same function over and over again, it's better just to write it out. So let's define a new function called mySum. And it takes 2 variables as input, num1 and num2, and it returns the summation of those 2 numbers. So now this allows us to be a lot more efficient in our later on, because we can simply call mySum with 2 input arguments and it'll print out what the sum is. Finally, we can do an object-oriented approach. So this is when you use classes, and the benefit for this is that you can define methods on this class or on this object. So I won't get into this too in depth, but essentially the main point is that you instantiate your class right here. So my calculator is the class. It takes your 2 numbers as input and it creates an object. Now this object has the methods that were defined in the class. So in this case, It has a summation method, a multiplication method, a division method, and we can simply call that using the period operator. So calc object dot my sum, and that does the summation for you on this object, specific object. Okay. So let's move on to some basic control flow now. So that means we'll be talking about loops and conditional statements. So you can, just like MATLAB, there's if, else if, else statements. And so let's take this, for example. Say you have a variable set to some floating point number, 25.4. If the variable is less than 10, print something. If it's less than 20, print something else, print large. And if you run this, it prints large because 25.4 is not less than 10, it's not less than 20, so it goes to the else statement. Next, we want to talk about loops. So the syntax for loops is slightly different than what it is in MATLAB, and they work slightly differently. So essentially, for looping over a set of numbers, the easiest way is just to say for I in range of 0 to 5, print I. And this will print, as you can see, 0, 1, 2, 3, 4. It's very important to note that it's not going to print out the last value. Some people get confused by this, where they expect this 5 to be outputted as well, but that's not the way this range function works. So that's just something to keep in mind. If you don't want to print out over a range of numbers, you can also print out directly from a list. So for example, let's print out the word in this list saying Python, MATLAB, Julia, C++. And you can print this out as well. And then, of course, you can combine loops with your if-else statements to print out, to get more complex control flows. Okay, so that's like the standard way of doing things. But in Python, there's something known as a list comprehension, which is quote unquote the Pythonic way to do things. And so we want to compress these loops into a single line. And the reason being is that there's usually the very slightest speed gain up to using list comprehension versus a for loop. So this was the normal loop syntax right here. For item and list, check if the conditional holds, and if it does, compute some expression on it. The list comprehension syntax is expression for item in list if conditional. So we're just taking this for loop and compressing it down into this single line. And I'll show you an example in the next slide. So this is a normal loop. Say we have a empty list called squares. We're going to loop over the numbers 0 through 9 and check if I is greater than 3, we're going to append I to the second power, and then we're going to print it. So when we output this, this normal loop, you get these values, which makes sense. When I is equal to 0, it's not greater than 3, so we don't append the power, and so on until we get to I equals 4, and then we go through. But we can also do this via list comprehension. So we can take this loop and compress it down into this line right here. So I to the second power for I in range 0 to 10 if I greater than 3. When we print this, we get the same list. Now, if you're curious, the reason why this is slightly faster than using a normal loop is actually because we don't have to continually append values to this empty list right here. We assume Python on the back end will handle that, and so it's just slightly faster. For such small operations, you're never going to notice a difference. You'd have to run this many, many thousands of times before you notice any actual speed up, any like functional speed up. But it is moderate. It is slightly faster. So if you're doing more complex list comprehensions or more complex loops, it does make sense to use a list comprehension. Okay. I just wanted to talk about variable naming conventions as well. And there's two reasons why you want to name your variables properly. First, you want to, it just helps others read your code later on. And it also helps you read your own code. When you come back to a file you haven't looked at in like, a couple of months, if your variables aren't named well, it can be really hard to figure out what it was doing. But it'll also help mitigate issues with variable overwriting / overloading. So I just wanted to bring your attention to this example right here. So let's set this variable num to the integer 3. And we're going to use this built-in Python function str. What this does is it converts the number into a string format. And if we print this, now this 3 is a string. It's not an integer. The reason why I bring this up is if you accidentally set string equals to a variable or to a number, so let's say string equals 5, num equals 3, and let's try to do the same thing. Let's try to convert num to a string using the built-in string function. It won't work because now string has been redefined as an integer. And the reason why I bring this up is I've made this mistake in the past where I've inadvertently set my variable name to something that's a like Python default, and it'll break your code later on without you realizing why it's not working. So you should be very careful with how you name your variables and just ensure that it's not overloading a Python like function or method. Okay, and for more information on this, you can go to the Style Conventions website. So if you go to this website right here, it's the style guide for Python code. It's extremely, extremely thorough. It's from the Python developer website. And it's just a resource for how to standardize your coding style. It covers everything from proper indentation to naming to commenting, documentation, etc. Okay, and finally, let's go over scientific Python. So most of you here will want to be using these, high efficiency scientific computation libraries. And for that, we need to install these external packages. So the most common ones would be NumPy, Pandas, Matplotlib, and SciPy. But there are countless others like scikit-image, scikit-learn, nebabble, so on, depending on what type of work you exactly do. So let's start with NumPy. So NumPy is for n-dimensional matrices. And it was specifically designed for efficient, fast computation. And you should definitely use NumPy in lieu of lists or normal Python arrays if you're working entirely with numeric data, because your operations will just be a lot faster. And for people that are MATLAB users or have a lot more familiarity with MATLAB, I would suggest checking out this resource right here. It's a NumPy for MATLAB users document where it's an extremely comprehensive resource where it compares MATLAB syntax to NumPy / SciPy syntax. And so if you're not familiar with how to do something in NumPy, you can just look up how you do it in MATLAB and compare it. Okay. So for NumPy, let's start with the basics. So how do you create an array? First, you need to import NumPy. So we're going to import this package. Next, we can create this array. So there are multiple ways to do this, and I'll go over a few of them. In this case, we're going to set this array to 0, 1, 2, 3, and we're going to set the type explicitly to a floating point number. And now when you print this array, you can see that it is an array of floating point numbers because you can see the periods. Its shape is 4 because it's a length 4 vector, and it's got a data type of float64. I just want to point out that if you don't explicitly set the data type, NumPy will keep the data in the same format that you placed it in. So in this second array, which is now a 2D array, you can see that the shape of this 2D array is 2 by 3 for 2 rows, 3 columns. You have 2 rows, 3 columns right here. And the data type is int32. So you should be mindful of whether you want to use int values or float values. And then you can also pre-allocate arrays. So if you want to make a 3 by 3 matrix of ones, you can use the ones function. If you want to make a zeros matrix, you can use the zeros function. If you want to make a diagonal identity matrix, you can use the I function, and so on. There are many, many functions in NumPy that you can look through at your leisure. But this covers the basics for how to instantiate arrays. So next, we want to talk about copies versus views. So a view of an array is created by slicing through it. So this is very important. This does not create a new array in memory. Instead, the same memory address is shared by the original array and the new sliced view. And changing the data on the view will change the data in the original array. And so if we want to change data, we should use the copy function. And let me show you what that means on the next slide. Okay. So let's create a new array. So we're going to create an array of from 0 to 9. And now we're going to take a view of that array. So we're going to use our list indexing. If you recall from my previous slide on list indexing, this :2 means we're going to take every second element. So now our new array B is 0, 2, 4, 6, 8. Let's change this view now. So we're going to say B of 0 equals 100. So we're setting the 0th index of this B array to 100, and we're going to print it. And now you see it's 100, 2, 4, 6, 8, as we expect. But if we print out the original array as well, we see that that was modified as well, which may or may not be what we wanted. If we didn't want this behavior, what we should do instead is copy it. So we're going to say A of, ::2 dot copy, which will force B into a new memory location so that when we take the 0th index and set it equals to 100, it does not change the original array A. Okay, so this is just something to keep in mind. Oftentimes we want to reduce across specific dimensions. So most NumPy functions have an axis variable that you can choose. So for example, let's instantiate an array of shape 2 by 3 of 0, 1, 2, 3, 4, 5. Now we can sum this array along the 0th axis, along the first axis, or along the both axes. And so what that means is if we sum along the 0th axis, we're summing down the column, so we get this array. If we're summing along the first axis, we're summing along the rows, so we get this. And if we don't specify an axis variable, it assumes we want to sum the entire matrix, which is why we get a single value. And this applies for most NumPy functions. So mean, argmax, min, max, cumsum, sort, etc. You can this axis variable is in most NumPy functions. Okay, so now that we have NumPy out of the way, there are many other useful scientific Python packages: Pandas, Matplotlib, SciPy, and NeBabel, and we'll cover a few of these. So Pandas is a very powerful data analysis and manipulation tool. Matplotlib is for plotting. SciPy is for highly efficient matrix processing functions like signal processing, morphologic operations, statistics, etc. And NeBabel is for loading of nifty format volumes, which is a very popular medical imaging format. So let's start with Pandas. So Pandas is a way to make a data frame object. So we're going to, as before, we're going to import Pandas, and then we're going to look at different ways to instantiate it. So we can instantiate it with a dictionary. So this format right here, if you recall, is a dictionary setup. You have A in, so this is your key, and your value is this list 1, 4. B is your key, your value is 2, 5. C is your key, your value is 3, 6. And we're going to instantiate this data frame with this dictionary, and you get something like this. So variables A, B, and C for, patient 0, patient 1. We can change around the columns with the columns variable. We can create a data frame from a list of dictionaries instead of just one dictionary. It's the same concept. You can create a data frame from a list, like it's written here, as long as you specify the column headers. It's the same concept. The entire point of using a data frame is that it's very easy to manipulate data once you have it in a data frame format. So let's create a new data frame. And so this is our new data frame. So you have variable A is a bunch of 1s and 2s. Variable B is mostly 0s and some 1s. And variable C is 0, 1, 2, all the way to 7. And now we want to do some sort of filtering. So let's find the values where A equals 2. And when we print this out, we see that A indeed only equals 2, and we filtered out wherever A equals 1. Similarly, you can chain together these filtering operations. So let's find where A equals 2, B equals 1, and C is greater than 5. And that only gives you one value left to search through. And so if you have very complex data, it's very easy to filter through your data frame to find the specific cases you're looking for. Next, we can talk quickly about visualizations in Python. So matplotlib is very similar to MATLAB syntax. So once again, we import matplotlib, and then it's extremely similar to MATLAB. So you have an X variable, you have a Y variable here, and you're plotting it, and you get the plot. You can set the X label, the Y label, the titles, and so on. If you wanted to make a bar or a histogram, you can make a histogram with the hist function. If you wanted to make like even more complicated graphs, you can do that as well. I won't necessarily go over this, but the matplotlib website has tons and tons of examples for many, many different types of visualizations you can make. You can also make visualizations in Python using a Pandas data frame. So for example, let's create a new data frame of just random numbers. And then let's plot those values for these 4 different headers. And you can see you can plot the values in your data frame extremely easily. It's simply just df.plot. Similarly, you can make histograms in the same way using your same data frame object, dataframe.plot.hist. Okay. Next, I'll very quickly go over some nifty volume processing. Nifties are very common in medical imaging just because they strip away all the patient information that's usually in the DICOM header. And so 99% of the work I do is in nifty. And so for that, this package, NeBabel, is very useful. So we're just going to look at how to use this. Once again, import NeBabel. We're going to load an MRI. And then we can view the summary. If you're curious, this is actually my brain, so it's not patient information. But yeah, this is the header struct, but it's not that important to go over. I'm just gonna skip this slide. This is actually pretty important though. So parallelizing operations, oftentimes we're, performing some sort of function on hundreds and hundreds of patients. And it would take many, many hours to days to run this sequentially on one patient to the next. And so there's a handy set of tools, packages you can use to parallelize functions across CPUs. So we're going to import multiprocessing and import this joblib. And okay, so let's look at how this works. So you're going to have a list of patients here. So this list contains all your patient file paths, and you're going to have some pre-processing function. It can do anything. For example, in this case, we're going to load in the patient volume. Then we're going to perform some processing of the data that can be, if you have neuroimaging data, that you usually want to bias correct the image or skull strip the image, something like that. And then you're going to save this process volume out again. Doing this sequentially would take way too long. Skull stripping and bias correction are pretty slow, and so you want to parallelize this across your CPUs. And so if you copy this line right here, this will parallelize it across how many CPUs you currently have access to. So if we look at this, pre-processing function is the function name. Patient volume is the input to this function. And we're doing this for patient volume in patients. So for every patient volume that's in our list patients right here. Okay. I'm just going to skip this slide. And one last thing before we end, I just want to go over some simple machine learning with scikit-learn. So sklearn has many, many machine learning implementations, ranging from simple things like regressions to classifications, dimensionality reduction, clustering, so on. And if you're interested, this very confusing map can kind of show you what to do if you go step by step through it. For the next example, we're going to focus on a very, very simple regression task, but you can, if you had other types of data, you could try to walk through this and figure out exactly what model or function you should be using. Let's do a simple linear regression to predict diabetes. So we're going to import pandas and sklearn. We're going to load this diabetes data set. It's a built-in data set into sklearn for testing purposes. We're going to put this into a pandas data frame. And next, we're going to split this into training and testing using this train test split function. And so at the very end, now we have our training and testing sets. Essentially what this means is that we have 353 patients with 10 variables each. So your variables are age, sex, BMI, mean arterial pressure, and so on, LDL, HDL, other things. And we want to create a linear regression to predict your glucose level. And so if we fit a linear regression to this, to the training set, we now have a model, and we can predict this, use this model to predict on the test set to see how good we are. And this is the test set prediction. So you can see the true values versus the predictions. The linear regression does fairly well. You could use more complicated models later on, though. But I believe that's it for me. So I wanted to thank you for listening to my talk and open it up for questions.
Thanks a lot, Jay. That was a great talk, and we have tons and tons of questions. So I think I'll start with the more general questions and go into more specific details. So here's one question that one of the listeners had. He said, if someone already knows MATLAB and is proficient using it, is there a compelling reason for why he or she should invest time and effort into learning another programming language? For example, is there something that you can do in Python that cannot be done in MATLAB?
That's a good question. So Python is a lot better in some cases for indexing through matrices. So Python's n-dimensional, support is a lot stronger. I didn't show any examples, but if you're using very high dimensional data, then I think Python makes it a lot easier to filter through that data and sort through it, I guess. MATLAB is completely acceptable for, if you're just doing, very low dimensional 2D or 3D imaging type stuff. But I also personally don't really see that much of a difference between Python and MATLAB. I do a lot of work in both languages. In fact, I sometimes prefer MATLAB for certain things, and I prefer Python for other things. For example, for specialized packages, I use Python. For example, bias correction and skull stripping. The packages that I use are, written in Python, and I'm not aware of a MATLAB analog for them. And so in that case, I'd use Python. But I actually sometimes find plotting and visualizations easier in MATLAB, so I'll use MATLAB for that. But it does come down to personal preference, I think.
So a related question is, between MATLAB and Python, which one would you use if you wanted to do machine learning?
I would use Python, just because the community for machine learning is a lot more developed and a lot larger in Python than it is in MATLAB. So scikit-learn has some, more classical machine learning methods like SVMs and random forests, which MATLAB also has very good implementations of. But if you wanted to do cutting edge deep learning, I think your best, bet would be to use TensorFlow or PyTorch or a similar library in Python. I don't know of anyone that does, cutting edge deep learning or cutting edge machine learning in MATLAB. And so it really comes down to your use case, right? If all you're going to be doing is, random forests, regressions, support vector machines, then it doesn't particularly matter. But if you wanted to do, deep learning based work, definitely Python.
Yeah, I think I agree with that quite a lot, because a lot of statistics folks tend to prefer R, and that's just because the libraries there are more mature. And I think one more point that could be added is that Python is a very general purpose programming language as opposed to MATLAB. So that's that can be sometimes handy as well. And then another person asked, does Python also handle multi-threading? You talked about multiprocessing. Does Python also handle multi-threading?
Yeah, so I'm not as familiar with this, but if you look at that that multiprocessing /joblib package, if you go to the documentation, there are flags you can set for using threads directly. I don't personally do that, so I'm not as familiar, but I know that is a capability of that package.
All right. And then the next question is, did you, so you talked about list comprehension. So and you said that it was slightly faster. Do you have any idea how much the speed up is?
It's not, I shouldn't have even mentioned that. It's not faster in terms of like, the only way it'd be faster is if you're running that example I gave you like 100,000 times. Like if you're only doing like very small computation, you're never going to notice a difference. It's only when you get into like, you know, very, very large scale data processing that you'll see that speed up performance. And I mean like very large scale. So
Right. Okay.
you can test it yourself with like the built-in Python like time functions to see how long the loop runs versus how long the list comprehension runs, and you functionally you wouldn't notice a difference unless you had, you know, thousands upon thousands of, you know, data points or iterations of that.
Got it. So the next question is, why would you use lists over arrays in Python, or vice versa? Which one should you prefer and why?
So lists can be any arbitrarily typed, I guess. So each element in a list does not need to be like, they don't all need to be integers or they don't all need to be floats. And so lists give you a lot of flexibility, whereas with NumPy arrays, it's just cleaner to keep them all the same data type. And so you should use lists if you foresee, you know, having mixed data types in your data set. But otherwise, if you're doing entirely numerical work, then you should almost always use NumPy arrays.
Got it. And then the next question is, does Python use semicolons to suppress the output? I don't know if you use semicolons in your presentation, but one of the participants has this question.
I did not use semicolons. So Python automatically suppresses output, I think. So if you like, if I just like zoom back to the very beginning of my PowerPoint, for example, like here, if I type in A equals NP a range of 10, it doesn't automatically print out A until I put print of A. The only time that you really need a semicolon is if you want to put two lines on the same, or two things on the same line. For example, if I wanted to move this print A up, I could do A equals this, semicolon space print A, and then they'd both be on the same line. But that's, I think, the only real use of a semicolon in Python.
So if I can add to that, I think there is a peculiarity of Jupyter Notebook is that if you are plotting something and you put a semicolon, it does suppress making two copies of the output on the Jupyter Notebook. But that's a very I think it's a peculiarity of Jupyter Notebook rather than a Python thing. All right, and then the next question is, okay, there's lots of questions here. What is the difference? Oh, 1 second. So the next question is, how do you, so one of the participants wants to know about the generator object. So is that something you can briefly touch upon, or where would you ask them to talk about? Yeah.
So yeah, Python has what are known as generators, which create like iteratively give you data. For example, I believe range is a generator. So if I were to like, yeah, so this thing right here is a generator, if I'm not mistaken. I'd have to look back. What that means is that it's not instantiating in a list per se. This is not making a list on the back end and then iterating through the list. It's creating a generator object, which is, you know, giving one value at a time, if I'm not mistaken. Functionally, I think it doesn't necessarily matter. you can look into like the Python documentation to learn more about generators and data consumers, but yeah, I'm not entirely an expert on that.
Yeah, I think generator basically allows you to it allows you to save memory in many
Yeah.
situations. So you can define, so if you have a complicated loop with some conditionals, you can define a generator, which is basically a function with this conditional, and then you can simplify your loop. So that's the context in which I've encountered it usually. Okay, and the final question, I think, is, okay, I think this would be the last question, is what is the difference between Python and SQL? And if you just wanted to start, manipulating data frames, like why would you use Python over SQL?
Yeah, once again, I'm not an expert on that. I don't know SQL. I only use Python for these types of things. Once again, it comes down to like, how many external packages do you know? If you know Pandas, then you're like, well on your way towards utilizing that SQL type framework. But really, I think most modern languages like Python have the functionality needed to do those types of tasks. And so not sure if it particularly matters which one you use. I don't know, maybe you know more on this.
No, I'm not an expert either on SQL. So
yeah,
I guess that's a good point to stop the discussion for today. It's been a great pleasure hosting you. Thank you for giving the talk. And for our participants, from the last week, we have been hosting the Why Now seminars on online on the webinar format. So this is probably going to continue. We're going to confirm with the speakers if they're still able to do this. And we'll keep you posted. Do sign up for our mailing list if you haven't already. And yeah, that's it. So see you soon.